board. That is essential. I want to make a couple of comments very quickly, just to address some various questions that have come to me over the past several days. So one comment, and I'm actually going to share my screen with you all just to be sure everyone's in the right place. So if you go to the My Open Math page, you have your first assignment due this Wednesday. Please be sure you get it done. Okay, a bunch of people have, not a problem, but I just want to be sure that everyone gets that in on time. I did send an email out to the class on Thursday. I tend to try to do that toward the end of the week, just so that everyone's up to date on assignments and what's due, because I know you have a lot to track. So there is a question, how do I access my homework? This is what I want to show you. So you go into our My Open Math page, you go to Unit 1, you go to Lesson 1, and then you click down here on Lesson 1 homework. Cool. All right. So that is the first thing. The second thing that I want to show you, if someone on Zoom could let me know, did it switch over? Did the screen switch over to the Moodle page?
Yeah, it did.
Cool. Thank you so much for letting me know that. So let me first make it so that it's your own view. So again, please make sure that you get the online homework done by midnight on Wednesday. What I want to show you in the Moodle page right now is you got to do a class activity in class together on Friday. Sometimes I do class time to do that. Sometimes I don't. But they're always announced when they are. If you were not here on Friday to get it, I do have some more copies here. You're welcome to have one. But they're also available on the class Moodle page. You can open it here and then you can print it from there. Okay. What I will say is if you hand it in to me physically, I will grade it and hand it back to you physically. If you email it to me, that's totally cool. I don't print out everything that I get by email though, okay? Because it's just too much paper. I will be posting the solutions to this on Wednesday after class, okay? It's due by class time on Wednesday, either via email or you can hand it in to me. But once that is over and everyone's handed it in by the due date, then I post the solutions so that you can look at any corrections or anything like that. But I will be handing them back. Those of you who did hand them in on Friday or email it to me this weekend, I actually got them graded. It was pretty smoky out and I'm sitting out back at home. I'm like, well, I'm just hanging out. I might as well get some reading done. I'll have some animals to keep me company. So I tend to like to get things graded right away. I think it's only respectful to get things back to you as soon as possible. If you are already running into difficulties on any of these things, I really want you to be sure that you are reviewing your class notes and asking questions in class as we move through the material, okay? This particular worksheet, kind of silly in one sense, but it was supposed to be conducive to you working with other people and talking about it. I like to do that for the group work. I will also add that if you have questions on these things at this time, you know, I can schedule office hours and I do schedule office hours, but really, I think what works best when people schedule office hours, they're like, okay, I'm in my office these hours of these days. Well, what happens if those hours of those days don't work for you, right? Then it's a total bummer. So what I want you to do is I want you to know that I'm happy to meet with you anytime that both of us are available. So if you have questions, the best way to make an appointment with me or come into my office is email me all of your available dates and times, and I'll find us a meeting with you. It means I'm meeting with students a lot more and in my office a lot more, but it also means that I'm like doing it with your schedule in mind, not just what's convenient for me. Okay, so if as the class is moving forward, you have any questions whatsoever, all you got to do is send me an email with all of your available dates and times that you can come to my office, or that if you would prefer to Zoom me, that's totally cool too. I'm flexible, and I'll find us some meeting to do. Okay, totally psyched to have people come in my office and ask questions, because honestly, that's the best way I have to get to know you all. All right. So that is that so far. Any questions or comments or anything? So I've got a couple other announcements that I want to make. If I just okay, so what I want to do is let you know that next week on Wednesday. Okay, and I'll announce it every class period. I'll email you. We're meeting on Zoom. I have to be in Billings for 2.5 days next week. And I have to be at the Board of Regents meeting, which means I'm just going to leave during our class time and we're consulting. Okay, so next Wednesday, we're all Zooming. Because I don't want to cancel class. I don't want to get us like it was cool that Ian's awesome, by the way. You all enjoyed him. But I can still teach class. I just need to be in Billings. Anyway, yes. Is that what we're doing? No, we're not having a test for quite some time. Yeah, don't worry. We got to get through lesson 5 or 6 before we're having our first test. Oh my gosh, no, everything in here is so totally announced way ahead. All right, so and last but not least, if anybody, our next worksheet will be when we finish lesson 2. We just barely started it last Wednesday, and I'm going to jump right into that in a moment, pick up where we left off. But I also want to add that if anybody has any questions on the online homework, if you're struggling with them, people have been messaging me, asking questions. When I've been able to answer within the homework system, I've been answering. When it's more written out work that I think you need to see the details, I've been getting back to you right away with that. And then I just write out the solutions in detail, and then I email that to you. So please keep asking questions, okay? Like, I'm so down with answering questions. It's my favorite part of my job. All right. So, and I'm happy if there's a lot of questions over something in particular on the online homework in class, I'm happy to answer questions at the start of class as well. But please be sure that this worksheet is turned into me by Wednesday in class, and that your online homework is done by midnight on Wednesday. Cool? Again, I do drop the 2 low worksheets. So if you miss one or you get a not so good score on one, don't sweat it. No one worksheet really affects your grade that much. And I also drop 2 low online homework scores. Okay. Obviously, you want to like jump in right away and try to do the best you can, but please know that there's always that wiggle room for you. Yeah? Y'all tired? Yeah, it's kind of a rough day, you know, with like the smoke and yeah. And the best part of my day might have already happened. And that was my run. Can't beat endorphins, so yeah. All right. Well, maybe the next part of this next thing will also be a great part of my day. What I want to do is pick up where we left off with the multiplication principle. Okay, remember where, and you may or may not recall, but I bet you'll pick up on it really quick. When you have a bunch of different choices to make, and each task can be done in a certain number of ways, then the total number of ways to do the tasks is you multiply the number for each one. So we saw, for example, last week that we had 3 choices for our carb for breakfast. We have 4 choices for our topping or lack thereof. And we found by drawing that little tree diagram that there were actually 12 different ways to choose breakfast, which is okay. As I mentioned last week, I always pick up where I left off. So I certainly do not expect that you have been thinking about math this entire weekend. So it's always a good idea before you come to class to kind of refresh yourself, just for tracking purposes. So we're going to dive in pretty deeply with this stuff. The thing is, you know, we don't want to just jump in the deep end without having like some built-in knowledge first. So I like to kind of ease us in. So what I'm going to do is I'm just going to continue working through several examples. Here's the deal. Stop me if you have a question. Cool? All right. So let's say this. What if I ask you this? How many different home styles are possible if a builder offers a choice of 6 basic plans, 3 roof styles, and 2 exterior finishes? Now, what I'm going to do as we proceed through these examples is I'm going to explain my thought process again, so that when you're on your own doing things, your mind will be geared on what to think about. Okay, this is especially relevant as we continue through this. So essentially, some builder is building in some area where all the houses kind of sort of look the same, but there's slight differences, right? And so if you want to build your house in this area, you have 6 basic plans to choose from. You got to pick a roof style and you've got to pick an exterior finish. Okay, so do you agree that we have 3 really important choices to make? Yeah. One of them is my basic plan. Another is my roof style. And my third is my exterior finish. Okay, notice I'm putting a line for each choice that I have to make. Well, how many basic plans do we have to choose from? 6. How many roof styles do we have to choose from? 3. And how many exterior finishes? 2. What does the multiplication principle tell us to do? Multiply. So how many different home styles are there? 36. What a thrill, huh? Questions there? Okay, let's follow up with a similar one. These are kind of good Monday morning things to do, right? A menu offers 3 salads. Told you I always talk about food. 8 main dishes and 7 desserts. How many times can you go to this restaurant selecting one of each category and not have the same meal twice? Wow, what a thrilling question. I mean, and there's only one place to go eat in town. You don't want to always have the same thing, right? So how many different options do you have for meals? Super cool. Well, again, we want to talk about how many choices do we have to make? We get to choose a salad. What else do we get to choose? Yeah, totally. And you make me think of my grandmother. My grandmother, whenever she would go out to eat, she would always order dessert first to be sure she always had room for dessert. Yeah, she was just the coolest. Anyway, and the main dish. Now, again, we could take into account somebody like my grandma because we have the commutative property of multiplication. It doesn't matter what order we multiply. So literally, if you wanted your dessert first, and then the main dish, and then the salad, that works. All right, how many salads do we have to choose from? 3. How many main dishes? 8. How many desserts? 7. What do? Multiply. We could go there 168 times and not have the same meal twice. You realize how many months that is? Isn't that wild-ish? Like over 5 months, you can go there for a half a meal. Listen, you got to find thrills where you can. And in math, you know, sometimes you got to really dig deep. All right, we're going to start getting a little more interesting. And I'll put interesting in quotes. Okay, so what if I tell you that there's a club and a club has 16 members? How many ways can this club select a slate of 3 officers if a person can only hold 1 office? And the slates are president, vice president, and secretary treasurer. Now, this is where it starts getting a little interesting. But I'll tell you that if you are not going to be in class tomorrow, you are totally going to want to access the class recording, okay? Because tomorrow we're going to dive really pretty deeply into this, okay? Just a heads up. All right, so we have 16 people in this club. And we need to pick a president, we need to pick a vice president, and then we need to pick a secretary / treasurer. The key thing is you can only hold one office, right? This is not going to be a dictatorship. Okay, so let's talk about this. And this is starting to lay some groundwork. Okay, and let's suppose we pick them in this order. Presumably you're going to pick your president first, okay, then vice president, and then treasurer. How many possible people do we have who could be president? 16. Okay, so notice up here, following what we've been doing, this is the number of ways to choose. Well, if there's a total of 16 people to choose from for the president, we're going to pick one. And that person can serve no other official places here. So how many people do we have left who could be vice president? 15. Okay, well, we have a total of 16 people. We've now selected 2 people to be something. Okay, they can't take on another role. So if we have 16 and 2 people have already been assigned, how many people can possibly be the secretary and treasurer? 14. That means there's 3,360 ways that we can put a slate of candidates. Isn't that cool? Do you see why we count down? Okay, they can't hold more than one office. So once we've already used them, they're done with. Okay, that's a really important thing to track. Okay. So you'll notice thus far, beneath each of my choices, I kind of outline what it is I'm needing to choose. And above that, I'm putting the number of choices I have. Do you see how that's kind of followed? Like these are the topics of what I had to choose. And up here on top are the number of choices I could make in each situation. Okay, keep this in mind. All right, so the next example is actually going to be 3 parts. It's kind of a silly thing, but whatever. A televised talk show, suppose, has 7 panelists. And let's say that there are 4 with brown eyes and 3 with blue eyes. My first question is, in how many different ways can they be seated in a row of 7 chairs? Do you all also see that all of these questions I'm asking in how many ways something can be done? Okay. There's my 7 chairs. Okay. Notice I'm not being particular. Okay. So you might be like, well, why'd you mention the eye color? You'll see. Okay. All right. How many possible people could sit here in this first chair? We have 7 people to choose from. And you might be like, who cares where you sit? But I would venture to say, if there's a table of food over here, this would be the choice seat, right? And over here, it would be a bummer. Okay. So do you agree any one of 7 people can sit here? We're gonna pick one though. So 7 people. See my fingers? This is really good. This is great that we have these fingers. Okay. We have 7 people to choose from, and someone is going to sit down. So how many people could possibly sit next to that person? 6. Okay. But now we've seated another person. So how many people could possibly go here? 5, but they sat down, then 4, then 3, 2, and 1. So there are 5,040 different ways that these people could sit in a row of chairs. My sets are getting pretty big now too, aren't they? Like if we had a set that showed every different ordering, there would be 5,040 elements in that set. Okay. Now, one comment. Do you see how I multiplied 7 times 6 times 5 times 4 times 3 times 2 times 1? Okay. There's actually a name when you do that, when you take some number and multiply by 1 less and keep going down all the way to 1. This is called 7 factorial. When I was a little kid, I called it 7 excited because I was just that sort of dork, really. Okay, but this is called a factorial. It's not a huge thing, but I'm going to be showing it to you in your calculator because sometimes it does come in handy to have that. But it's a factorial only if you start at that number and keep multiplying by 1 less all the way down to 1. Okay. All right. So same scenario. We still have 7 panelists. We've got 4 with brown eyes and 3 with blue eyes. Now I want to know in how many ways can they be seated if the people with eye colors, they all have eye colors. If the people must be alternated by eye color. In other words, 2 brown-eyed people can't sit next to each other and neither can 2 blue-eyed. As if we care. No, but pretend. Okay. So I will have us recall that there's 4 brown and 3 blue. All right, we still have 7 chairs. What do we have to start with? A brown-eyed person or a blue-eyed person? We got to start with the brown-eyed person. The reason why is we have more of them. If we started with a blue-eyed person, it would go blue, brown, blue, and then we'd have 2 browns. That can't happen. Okay, so since we have an odd number, we have more brown-eyed panelists. It's got to go brown, blue, brown, blue. All right, let's first deal with the brown-eyed people. Okay, how many brown-eyed people could possibly sit right here? 4, right? Do you agree that one of them is going to sit there though? Yeah, so how many brown-eyed people do we have who could possibly sit right here? 3, but that brown-eyed person's going to sit down. How many brown-eyed people do we have who could sit here? 2, and boy, it's really hard to have this be your only finger up. How many? 1. Okay. Now we could have started over here with, on this side, but it doesn't matter because it doesn't matter what order you multiply. Now let's talk about the blue-eyed folks. How many blue-eyed people could possibly sit here? 3, but one of them's going to sit there. So we have 2 who could go here and 1. if you multiply across, check that out. When we had no conditions on where people sat, we had 5,040 different seating arrangements. Now, when we started getting a little particular, we're down to only 144. It is. And I really appreciate you trying to find like some tinge of thrill in this. Yeah. All right. In how many ways, this is the last of these seating arrangements things we have, and then we're going to deal with numbers and it's going to get so fun. So in how many ways can they be seated if all the brown-eyed folks must sit together? And all the blue-eyed folks. I don't like thinking of segregating people by the color of their eyes, but you know, I feel like this is kind of a harmless. All right. Well, what does this mean? Well, here's the 7 chairs. Who do I put here? I could put a brown-eyed person, but then doesn't that mean that all my other brown-eyed people need to go here? You with me there? But remember, my friends, the food's over here and it's really good food. Okay. So isn't it kind of optimal to be over here? What's another possibility? Or couldn't we have the blue-eyed people get to be near the food? You see how there's 2 different possibilities here. Okay, again, in both of these situations, you have the brown eyes and the blue eyes sitting with each other. There's only the issue right here. Okay, but these are 2 different scenarios. Okay, so let's first deal with the top row. How many possible brown-eyed people could sit right here? 4. But someone's going to sit there. So how many possible brown-eyed people could go here? 3, then 1. How about blue eyes? 3, 2, 1. If you multiply across, you get 144. What does this second possibility look like? Well, how many blue-eyed people could possibly sit here? 3, then 2, 1. Do you all see why we're counting down? Okay, that's crucial. If you have a question, please don't be shy. You've got to ask. Don't let yourself be lost. Okay, and then my brown eyes, I got 4, 3, 2, 1. So we have 144 possibilities if the brown-eyed people get to sit near the food. And we have 144 possibilities if the blue-eyed people get to sit next to the food. So how many total possibilities are there? 288. One of the things you're going to see, we had 144 or 144, or is very often going to be associated with the operation of addition. Okay, we've talked about or relating to our union and relating to our intersection. Okay, as we move forward, or is also going to be related to addition and multiplication. All right. So let's get a little more interesting. I want you all to recall there are 10 digits. I showed you the set of digits the first day of class. We know that our set of digits consists of these numerals. Okay, if you don't know that, you need to know that there are 10 digits. Okay, so here's something somewhat practical. Suppose we want to create a 4-digit PIN, right? We just got an ATM card and we need to do a 4-digit PIN. How many pins are possible if, for this first one, now I'm really laying some important groundwork here. Okay, so I really implore you, gotta ask if you have questions. Okay, so do you agree we have 4 really important choices to make because we're creating a 4-digit PIN? Okay, now notice there's no restrictions. In other words, my PIN number could be 1111. It could be 0000. It could be, you know, it doesn't matter. Like there's no restrictions on what we're allowed to use. Okay, so notice we want to create a 4-digit PIN. So I have 4 choices to make. What I want to emphasize is up here are the number of choices you have. How many possible digits could we pick for our first number in our PIN? 10, because there's 10 digits. Okay, there's no restrictions, so I can use that one again if I care to. How many choices for digits do we have here? 10. How about here? 10 and 10. So that means that there are 10,000 possible pins. Okay, what if now I still want to choose a 4-digit PIN, but suppose now there's rules that are starting to be put on me. Gosh, I hate that. But now suppose no repetition is allowed. In other words, once you use a digit, you can't use that digit again. Kind of like once somebody sat in a spot, they couldn't sit in another spot. You with me? Okay. So I still have 4 very important choices to make. Underneath here, I'm going to write no rep. That's my own way to track things, like I'm not allowed to repeat. Okay. And up here are the number of ways to choose. How many possible digits do we have for our first one to choose from? 10. Okay. But I can't use that one again. So how many possible digits do I have to choose from next? 9. But now we started with 10 digits and we've used 2 of them. So how many possible digits do I have to choose from next? 8 and then 7. And it turns out if you multiply across, you get 5,040. We've seen that number already. Now we're going to start getting funkier and funkier. So I want to be sure that first off, you see, like we almost had half as many choices once we got into this from no restriction to no repetition. Okay, you need to know what no repetition means. You'll see this a lot. Okay, same thing, but now what if I tell you that your PIN number must start with a 4 and repetition is okay? Good. Okay, underneath here is where I put any restrictions. Up here is the number of ways to choose. Okay. Now, my hint to you, and this is huge, whenever you're doing these, you want to start with the most restrictive place first. Okay. So I think you'll grant me that this is the most restrictive place because they're telling us it's got to be a 4. From here on over, we're cool. Okay. So in how many ways, remember, up here is the number of ways to choose. In how many ways can we choose a 4? There's one way to choose a 4. You choose it. The most common mistake people make is they put a 4 up here. There are not 4 ways to choose a 4. That's why I really differentiate between my restrictions beneath and the number of ways to choose up above. Okay, there's only one way to pick a 4. Now, do I have any restrictions here? No, so how many digits do I have to choose from? 10. How about here? 10 and 10. So now we have 1,000 pins. If there is a question, please do not hesitate to ask. What if it must start with a 4 and no repetition is allowed? Now you see how I'm taking the time to label this and put my restrictions underneath. I cannot overemphasize the importance of doing that because when you're picking numbers and you have the number of ways to choose numbers, you've got to really make that separation. Okay. Now, we still need to start with the most restrictive place first. And I think being told that something has to happen is pretty darn restrictive. You agree? Yeah, makes me want to run away when people tell me what I have to do, but that's just me. All right, so we got to pick a 4 here. In how many ways can we pick a 4? 1, there's only one 4. Okay, you with me there? Okay, so there's 10 digits. We picked a 4. Notice, because no repetition is allowed, I've got to take that away from the rest of my choices. So how many digits do we have left to choose from now? 9. And now I've selected 2 digits. One's a 4 and one is something else. I could care less. How many digits do we have to choose from now? 8. And then once we choose that, 7. All right. Now we're going to get fun. How about we do one more for today? Okay. But I'm going to pick right up with this tomorrow because this is huge. Suppose now it must start with a 4. It cannot end in a 9. And repetition is okay. Tomorrow, we're going to do one similar to this, but repetition won't be okay. So I suggest look over this one last guide tonight before tomorrow. Okay. You start with the most restrictive place first. Totally. Do you agree it's a lot more restrictive to tell us something has to be versus it can't be one of them? This is more restrictive. In how many ways can I pick a 4? One way. Over here, I cannot have a 9. Am I allowed to have a 4 here? Yeah, because repetition is okay. So if I have 10 digits and one of them is discluded, how many possibilities do I have here? 9. Do I have any limitations in either one of these places? No, so 10 and 10. Now, when repetition is not okay, we'll do that first thing tomorrow morning. Cliffhanger. I know. Why wouldn't this end? It doesn't say it has to be a 9. It says it cannot be a 9. Okay, so if you have 10 digits, Ani, and you can't have a 9, then you have 9 choices. If I said this must be a 9, then you're right. It would be 1 right here.
Do you have the worksheets? Can I ask you a question?